Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 68. Text Justification. This is a legendary string challenge that tests your precision with greedy packing and space distribution. It is a favorite at top companies like Google and Facebook. Let us look at the problem statement. We have a list of words and a maximum width. Our goal is to pack these words into lines as tightly as possible, while keeping each line exactly at the target width. The rules are simple: we pack as many words as we can, then we justify the line by spreading extra spaces evenly between words. If the spaces cannot be divided perfectly, the leftmost slots get the extras. But beware, the very last line is special, it is only left justified with single spaces. Think of it like a professional typesetter for a luxury magazine. You have a fixed column width. You place your word blocks in a row, and if there is a gap at the end, you carefully stretch the spaces between words to make both sides align perfectly with the margins. This is what we call full justification. For the last line, you just let it sit naturally on the left, just like the end of a paragraph in a book. Now, let us look at the algorithmic strategy. We use a greedy approach. We keep a current line list. We add words one by one, adding their length plus one space for each gap. If adding the next word makes the line longer than the max width, we stop and justify the current line. For the math, we find the total empty space by subtracting word lengths from the max width. Then, we distribute those spaces using the modulo operator. This ensures the left slots get one extra space whenever the division has a remainder. Let us dive into a crystal clear dry run. Look at the words. This is an example of text justification, and our width is 16. We start packing. This, length 4, is length 2, and length 2. Total word length is 8. Including 2 single spaces, the width is 10. If we add example, which is 7, we hit 17. That is over our limit. So, line 1 is this. Is un. Now, we justify. Max width 16, minus word length 8, leaves 8 spaces to fill. We have 2 slots between the 3 words. 8 divided by 2 is 4. So each slot gets exactly 4 spaces. This 4 spaces is 4 spaces and line 1 is perfect. Moving to line 2. We start with example of text. Total word length is 13. Adding justification, which is 13, is way too much. So line 2 is example of text. 16 minus 13 words leaves 3 spaces. We have 2 slots. 3 divided by 2 is 1, with 1 remainder. The first slot gets 1 plus 1 equals 2 spaces. The second slot gets just 1. Example, 2 spaces of 1 space text. Done. Finally, we have justification left. This is the last line. We left justified, and pad the remaining spaces at the very end to reach width 16. Beautifully justified. Now, let us look at the Python implementation. We track numofletters for the words, and len, cur, for the number of words. The condition numofletters plus len, w, plus len, cur, checks if the new word, plus its mandatory space, fits. Inside the justification loop, we use I modulo number of slots to distribute spaces. This is the secret sauce. It automatically gives extra spaces to the left slots until they are all used up. For the last line, we just use a simple left justify function. Looking at the complexity, the time complexity is O of n, where n is the total number of characters. We only pass through the words once. The space complexity is also O of n, as we build the final list of strings. And that is text justification mastered. Save this video for your next technical interview, and follow Leo Academy for more 10x premium DSA guides.